Hi, Dave here. I thought I'd create a tutorial video to explain how to process a double star observation when the length of the observed chords are longer than the assumed diameter of the asteroid as determined by one of the IR satellites, NEOWISE or whatever. So, Uh, Ernie sent me this initial plot where Paul Malley has a double star observation that is significantly longer than the assumed diameter. And my first reaction was, oh wow, the miss chord here by David Dunham might become important because it might restrict the number of solutions. Normally, when you get um, a single chord double star observation, you end up with 4 solutions. So in this particular case, um, at this stage, I thought the missed chord might restrict the solutions to 1 or 2 solutions rather than the usual 4. So I asked Ernie, did he have the David Dunham CSV file or Joan Dunham? I don't know who pronounced it, and he said he did. So he sent me a Vizier light curve. Long story short, we ended up having getting a good um, representation of the miss observation. Um, so I'll get stuck into processing this now, but that's a bit of the history. We'll fire up Occult. Before we do that, get out of the way, you. In the event where I've put the data is in Joan and Ernie. It's Elsa. Now, these are the Vizier light curves that are involved. And now, if you want them to pop up when you open the OBS file, you copy them into, I've got a quick access folder here, but you go into the occult directory and it's the light curve reports folder. Open that and just paste them into there, so that when the OBS opens, that they'll pop up. So get rid of that. So now we'll open up the OBS file itself so you can see what's going on. Come on. Open. I keep it in there. Joan and Ernie. Here we go. So you can see there's the 2 light curves, and it's reminding me that we haven't completed it. That's okay. We got a shape model. I normally Alt M turns off and on the shape models. So I usually drag that down here out of the way, and I drag this down a little bit about there, so it's not in the way. And turn off the shape models for a moment. Again, Alt M. So here's the Vizier light curves. Paul's got a point on the disappearance, an intermediate point. It's only 1 point, and that's typical of a magnitude 7.5 star disappearing instantaneously. However, over here, we'll have a look at this a bit closer in a minute. There's 4 points on the R, and again with an intermediate point here. So that's a typical double star reappearance. So that is A and B disappear together on the on this side, and the B star reappears first, followed by the A star because it's bigger. We can open up the light curve viewer, and that's over here. We drag this over here, and there's the 2 files I have in that directory, where I can open that one up and I can zoom in a bit. So you can clearly see there's a step of 4 points, which is very, very good. We can right click here and get a baseline, and we can see here by mousing it over, it's 73% drop there down to we'll call it 100%. If we right click here again, we can see that the reappearance. Okay, so it's a 73 or thereabouts, and 100 and the rest. So the B star and then the A star. Ernie has, as par, he's got a 74 and 75, which add up to expected drop of 99%. So we'll go with that. So that's fine, Ernie. That's great. Now, just for completeness, because I can, I'll get rid of that. In my wisdom, or not, I've verified those times using IOTA. Where are we? Joan and Ernie, Elsa. I've used IOTA. The times are exactly the same, but the errors are a little bit different. There's the disappearance using IOTA, and that's the A star, I beg your pardon, reappearance, and that's the B star reappearance. So the times are pretty common. It's just the way IOTA computes the plus and minus errors are a little bit larger than the PIOTA. So I'm happy with all that. I hope that's clear. So here we have the limb plot. Now, this assumed diameter circle, we go up to list and down to the IR, so we can see that the assumed diameter is computed by a weighted average of the NEOWISE, AccuA, and the IRAS satellites. So the computation is 42.5 kilometers in diameter, plus or minus 2.6. So whatever we do, the equivalent of an ellipse or anything like that has to be 42.5 or 43 kilometers to be valid. I hope that's clear. So there's, you've got the disappearance and then the 2 reappearances. Now I like, because the reappearance of the B star occurred earlier, it's not 100% necessary, but I like to get them in sequence. So here, the disappearance times should be the same, and they are, but the reappearance times, I like the earlier one higher in the in the tree, in the sequence, I should say. So that's the way I like it. So that's why I'm doing it. That way, it doesn't affect anything, but that way you get a logical sequence here. So 2 and 3 are together, then 2, then 3. Now, because the longest event is the A star, we turn on the primary event, which is chord 3, and we have no choice other than to increase to create an ellipse to fit to that those points. So we turn off the assumed diameter, we turn off the circular, we turn we might leave the circular on for a moment, and what I normally do is I increase this to get it to fit to the points, which is about, well, a better way, yes, a better way is to go up to the list chord lengths, and the longest chord, which is chord 3, is 59.1. So now you can, rather than trying to guess, you can type in 59.1 is the length of the chord. End of story. Now we can turn off circular. Now, the assumed diameter, as discussed before, is 42.5 kilometers. The equivalent diameter of an ellipse by area at the moment is 59.1 kilometers. So we need to reduce the minor axis by an amount, and I don't know. You could sit here for a minute and calm down until these two match. 37, 40, 47. So we need 42.5 there. So an assumed diameter circle has an ellipse of the same area of major axis of 59.1 by 30.5. So you can see here the assumed diameter 42.5, and the equivalent diameter of the by area of the ellipse is 42.5. I hope that's clear. And then now we rotate the orientation to be parallel to the chords. Well, that's about right. That'll do. So in this particular example, the A star is set. We don't set the north and south limbs like we'd normally do for a single chord event, because it's at the maximum. So now we simply turn off these settings so that it doesn't get altered during the process. Now we turn on the secondary event, and you can see the two there, and then we might move this up a bit. So now we guide occult into a solution. I don't know what the solutions will be. So We'll do the north limb first for the B star. So we help it along by setting the separation, and it'll immediately pop out a line to represent the double separation and position angle. And all we do is use this find best fit button. It's too far, I think. Come on. Here we go. No, too big. You got to get it pretty close. Come on, be nice. Oh, hang on. That you got to turn on the activate the find best fit check boxes, and then we go bang. Easy. Now we've fitted the north limb. I forgot. I forgot all about this. It's a there'll be two solutions. So it's a multiple chord for one, single for other. Two solutions. I forgot. My fault. So that's turned on the that's made these colors solid. So we've set solution one, and now we need to the PA is going to be something like about 180, and we guide occult down south, and now we can fit the solution to the southern limb. So now we've got two solutions: northern solution, southern solution. The PA should be pretty much the same. Yeah, 3.3. Sorry, the separation is 3.3. The PAs are about 180 degrees apart. Yeah, a bit less. So now you can look at both stars, and my initial worry about the Dunham miss was ill-founded, because they're not affecting the two solutions. Now, to double check that is correct, the old method of showing the double star solutions was to show the profile of the best fit ellipse as two stars. So you can see here, now we've got yellow for the A star and orange for the B star, and you can see the B star still missed Jones and David's miss. So there and there. So the miss was a true miss for both stars. You should always check the unaligned primary and secondary events to make sure that you've got you haven't made an erroneous solution. So once again, these are the two solutions. Now, for some reason, it hasn't updated here. I don't know why. Let me, solutions, double stars, list. Where are they gone? Here we go. They're the two solutions that will be sent into the JDSO and then on to WDS. Might put that there. They've now updated. Here they are here. Takes a while, I guess. All right. Now, what I would do for my... don't worry, that's just a dog. Fell off the bed. It's raining outside, so she can come inside. Now, so that's about it. Now, what I do, just for fun, is I save a plot. What I might do is I might drag that up to there, and I save the plot. Save this image. I give it the same name. No, I don't. I give it the same name as the OBS file. No, not in the right folder yet. Ernie and Joan, Elsa, 2. I give it the same name as the OBS file just for fun. Okay, so I show that solution, and then I will drag this down here and take a screenshot. Of here. Come on, yep. Copy to the clipboard. Open up the folder again. Elsa. There's the plot we just made. Open it in Paint, and I'll paste it here. Something like this to show the two solutions. Bang. Oh, that didn't work out, did it? I know what I forgot to do. Undo. I'm just going to put that over the second. Everybody's watching. There we go. That's the second. Oh, I've got them the wrong way around. You got the idea. So if I was creating something for the website, that's what I'm trying to copy to the clipboard, drag this back, paste. There we go. That's showing the two solutions. You can do that with a bit more care. And if you wanted to, you could even grab a copy of this to make something for the results page. Copy and put this here, showing the two solutions like I really meant to do it. Save. Clear as mud. I hope so. It's a bit clearer than mud. I might say, there's the, I don't know, I must have done it before while I was mucking around. You have to put in the relative magnitudes. So I'd already done that while I was playing around, so I hadn't forgotten. So save. So that's how you fit a double star solution where the length of the chords is longer than the assumed diameter. Hope that's clear. Save it again. You can't save it enough. All right, so I will shut down Occult and I'll stop the recording. Hope that helps. All the best. Dave out. Bye for now.